All right, polynomials, this is easy. Put them in order. When I say in order, I mean by the exponent, not by the number in front of it, okay? So your highest exponent then is going to be this one right here. So we're going to start with the 4m to the 6th. The next one is the negative 10m to the 4th. So include that negative as your minus. Then we have negative 6m squared and negative 10. That is very easy. That is standard form. You've answered that piece of it. The leading coefficient, once you have it in standard form, your leading coefficient is the very first number. So that's just a 4. So that's your leading coefficient. Name each polynomial by number of terms. Remember, you have monomial 1, binomial 2, trinomial 3, but from there, just say 4 terms, okay? So this is going to be 4 term, and the degree is your highest exponent. So my degree is going to be that highest exponent of 6. Simplify right here just means combine like terms. So I always start with my highest exponent here and I underline them to make sure that I did it correctly. So I have like negative 5 to the v to the 4th, and this is a plus. So plus 6v to the 4th. Those are like terms. And then I always do a plus here. So I have a positive v squared and it's plus 8v squared. Those are like terms. And then I have an 8 right here plus 8. So I've kind of grouped my like terms. And then I'm just going to combine those. So I have negative 5 and positive 6. That is a 1v to the 4th. 1v squared and 8v squared is 9v squared. And then 8 and 8 is positive 16. And that's my answer. This is foiling. Foil, that's first, outer, inner. There we go. All right, so first, 7n times 7n is 49n squared. Yep. And then we have 7n times 3. That's just 21n. Negative 1n times 7n, so that's negative 7n. And then we have negative 1 times positive 3, negative 3. Combine anything you have in common. 49n squared does not have anything to combine. 21 and negative 7 is a positive 14. And then we have a negative 3. And that is our answer there. This one is a special case. If you don't remember the special case, you can foil it. If you do remember it, then this is just the same exact terms with 1 plus and 1 minus. So it is going to be the first one squared, always minus the second one squared. If you don't remember that, you can foil. The inner terms cancel when it looks like this. So that's why it ends up like this. When I square 2n, I get 4n squared minus this guy is 64. But if you don't remember that, foil it.
Yeah,
all right, the first thing we're going to do is just take out the common factor. So you can stop there. All it wants you to do is find what's in common to all of them. So you look at 56, at 40, and at 24, and you say, okay, I have an 8 in common. You look at n cubed, n squared, and n, and you do your lowest one, which is n. All right? Then you just divide. 56 divided by 8 is 7. I had n cubed. I took out one of them. I have n squared. Plus 40 divided by 8 is 5. I had 2 n's, I took out 1. And then 24, remember this is a minus, 24 divided by 8 is 3. I had 1 n, I took out 1, I don't have any left. That's all you have to do if it says take out the common factor, okay? You don't have to unfoil it, right? They just want a common factor. When it says factor completely, then you have to either factor by grouping like we're about to do, or you have to actually unfoil. You have to get 2 groups, right? So factor completely with 4 terms, you're going to factor by grouping. So group the first 2, group the last 2. All right, so I'm going to look at this first group and just do common factor. So I'm going to say, well, a 6 can come out and an x squared can come out. So I'm going to take a 6x squared out of this first group. 6 divided by 6 is 1, and then I took out 2 of my x's. Minus 12 divided by 6, that's 2, and I took out both of my x's. Always put whatever you have in between here. That's a plus, so put a plus. For this second group, I don't have anything in common between an x and a 2, so I'm going to list a 1, all right? And then I'm just going to have the x minus 2. That is my first step in factoring by grouping. Group it and take out the common factor. Then I want to say, well, these two should be exactly the same. If I factored correctly, they should be the same, and that's going to be one of my groups. The second group is going to come from what's on the outside, 6x squared plus 1. And that is my answer. And to figure out if you did it right, you could FOIL it. Right? For the next one, when you see something like 84 and 4, chances are good you have something in common to take out, okay? So, what do I have in common between 4, 38, and 84?
2.
Yeah, 2 actually is, yeah. So it start with a 2. If you still have an even number across the board when you take out a 2, then you'll be able to take out another one, which is technically 4. So we are going to take out the 2 first. We will have 2v squared minus 19v plus 42. All right. Now this is where we multiply across. So you are going to multiply across. 2 times 48 is 84. Factors of 84 that give me 19, all right? So if you don't know your factors of 84 that would do that, just start listing them. 1 times 84, 2 times 42. 3 does go into it. So 3 times what? 28. There we go. 4 will go into it. 4 and 21. 6 goes into 1 and 14. Your exam yet?
No, yeah, you really got caught.
Right. Once you figure out what it is, you are going to rewrite this guy right here. So we're going to leave that alone. Then we're going to say, we're going to change this one to match the ones that we found. So minus 7v minus 12v plus 42. All right. You'll notice we have 4 terms. We are going to factor this just like we factored 4 terms up here. So we're going to group it and factor. Remember, when you group behind a negative, you change the sign. So we have 2. And then from the 2v and the 7v, we can take out a v. We're left with 2v minus 7. Don't forget a minus. Between the 12 and the 42, we can take out a 6, and we're left with 2v minus 7, which is how it should be. And then you're just going to finish it. We have a 2, we have a 2v minus 7, and we have a v minus 6. And that is our factoring. Chapter 11 dealt with simplifying radicals. So to simplify a radical, you need to use your factor tree. And then you need to look at your index and see how many pair up to come out. So in this case, we have square roots. So we are going to simplify that 50 by just factoring it. 2 and 25, 5 and 5. And so you're going to say, well, if it pairs up, it's going to come out. So I have a 5 that can come out. I have a 2 that will stay in. Then I am going to look at my variables. I have an x to the first power. So that is just 1x. There is nothing to pair up with it. So the x is going to go on the inside. And then I am going to look at my y's. I have y to the third power. So you can think of it like just 3 y's. And you can group that the same way we did our numbers. 1 pair will come out because it groups. This y will stay in because it has nothing to group with. And so this will be my answer, 5y square root of 2xy. When you are multiplying radicals like number 26, you can factor everything and then group anything that comes out together. So for this first one, I can say, well, 5 and 13. And then for this one's a little bit difficult of a factoring. It's 11 and 13. But between both of them, I actually can pair up these 13s. So I can actually take a 13 out. When I look at the variables, I have a p squared and a p squared, which is actually 4 of those variables. And so I can group a p right here, and another p will group. And I don't have any that will stay in. On the inside, all I have is a 5 and an 11. And so to simplify it, I'm going to multiply what I have on the outside. 13 times p is 13p squared. And on the inside, I have 5 times 11, which is 55. And so that is my answer for number 26. For number 27, I am going to do distribution. So remember, you can multiply outside to outside, inside to inside. So I have the square root of 10 times 5 plus the square root of 10 times 6. Remember, I can simplify all of these. 10 is 2 and 5, and then the 5 is already simple. When I'm multiplying, that's all I can group together. So I can take the 5 out, the 2 will stay in. On the next one, I have a 5 and a 2 for that 10, and a 2 and a 3 for the 6. I can take a 2 out here, and the 5 and the 3 will stay in, which is 15. And since those are not like terms, I'm going to leave that as 5 square root of 2, 2 square root of 15. For division, I am going to simplify each piece before I do anything else. And so I can only simplify outside to outside and inside to inside. So I'm going to look at my 7 and my 2. Those do not reduce, so I'm going to leave them alone. X and x squared, I can take out one x out of each of them. So that x will go away, and I can take one x out of the... For my y's, I have 3 in the bottom and 4 in the top, so I can take 3 out of each of those. That will take all 3 of those out of the bottom and all but 1 out of the top. And so I have 7y over 2x, and they're both in radicals. I need to get rid of my radicals in the denominator. So once I've simplified everything that I can, then I am going to multiply everything by the radical that's in my denominator. So I'm going to multiply this by the square root of 2x, and the top by the square root of 2x. And then I just multiply what's inside. 7 times 2, that's 14, and I have an x and a y. And on the bottom, remember when I multiply a radical by itself, I just get what was inside. Now if you look, I do have a 14 and a 2, and you may think, oh, that can reduce, or the x's can reduce. But remember, the 14 is on the inside, the 2 is on the outside. I cannot reduce outside to inside, so I'm actually done here. When you are adding radicals, they have to be the same exact radical. So when I look at these, to know if I can add them, I have to look and say, is this the same as this one and this one? And if it is, then I can add them. And all I do is add the coefficients. 3 plus 2 plus 3. That gives me 8 square root of 5. All right, we did move into right triangles. And for right triangles, if you are trying to find a missing side, remember we are going to use the Pythagorean Theorem, which is a squared plus b squared equals c squared. Remember, it doesn't matter which side is a and b, but you do need to know that the hypotenuse, which is the side opposite of your right angle, is always c. So to solve for this, I would say x squared plus 12 squared equals 15 squared. And then I am just simplifying them. X squared plus 144 equals 225. Subtract the 144. We have x squared equals 81. And then I'm going to take my square root. So remember, when I'm talking about side length is always positive, so x is going to equal positive 9. For distance and midpoint, you want to remember your formulas. Remember the distance formula. You're going to subtract your x's and square it. Add that to what happens when you subtract your y's and square it, and then take the square root. So if this is my first group and this is my second group, so I'm going to say the square root then of x2 minus x1, square that, plus y2 minus y1, and square that. And remember, anytime I square a number, it's going to be positive. So even though this is a negative 4, when I square it, it will be positive. I have the square root of 16 plus 4, which is the square root of 20. And I do want to simplify that. So if I use my factor tree, you will see that you can take a 2 out and a 5 will stay in. So that's the same thing as 2 times the square root of 5. The midpoint formula. The midpoint formula will give you 2 points, an x and a y. For this one, you just add your 2 x's and divide by 2, and that will be your x value. Add your 2 y's and divide by 2, and that will be your y value. So if I have my x1 and y1, x2 and y2, I'm just going to add them. 5 plus 6 divided by 2, negative 7 plus 6 divided by 2. So I have 11 halves, which you are welcome to leave as an improper fraction. And then I have negative 1 half. And that is my answer. The last chapter that we covered dealt with solving equations. The first way that we solved was by factoring. So if it's already factored for you, you're just going to set each of those groups equal to 0 and solve. So you may need to add or subtract, multiply or divide to get your answers. But once you have the variable by itself, those will be your answers. If it is not factored for you, you will have to factor it. Keep in mind, it must equal 0 in order to solve by factoring. And so if it doesn't, you need to move that number over. So it's a plus 3, we need to subtract a 3 there. So now I have n squared plus 15n plus 56 equals 0. And now I can factor. Factors of 56 that add up to 15 are 8 and 7. And so now it looks just like the one above it. I can set each one of these equal to 0 and solve. The next method that we used was taking the square root. When you're taking the square root, you want to get the square by itself. So the first thing I'm going to do is subtract that 1 over, and I have x squared equals 81. Then I want to take the root of both sides. Now in this case, we're not talking about a side length. So anytime you take a square root with a radical, you have to consider the positive and negative root. So the square root of 81 here is going to be either positive or negative 9. We then solve by completing the square. And so the first thing we need to recognize is how do we complete the square? You complete the square by taking that number in front of the variable that's in the middle, b, your b value, and you're going to divide it by 2. If it's not evenly divisible by 2, just leave it as a fraction. And then you are going to square it. You do square both pieces, so square the numerator. And remember, it's always going to be positive. Negative 5 squared is positive 25. 2 squared is positive 4, and you can leave it just like that. So then we used that to complete the square. So unlike factoring and quadratic formula, to complete the square, you actually just want these first 2 pieces by themselves. So we're going to move this negative 4 over first. We have n squared minus 6n equals 4. And now we're going to do what we did on the other page. We're going to complete that square by taking this number, cutting it in half. That's going to give us negative 3. And then we are going to square it, which gives us a positive 9. And so we are going to add that 9 to both sides of the equation. On the left side, we want to factor, but it's really simple because it's always going to be my variable and whatever I had right here, which is a minus 3. On the right-hand side, we just add. 4 and 9 gives us 13. I'm now going to take the square root of both sides. On the left, I have just the n minus 3. On the right, since 13 does not have a perfect root, I'm going to leave that there. But remember that I have a positive and negative. And then my final step is move that 3 over. Now, because the 3 is not inside the root and the 13 is, they're not like terms. And so I'm just going to leave it as 3 plus or minus the square root of 13. So the final way that we solved was using the quadratic formula. First, make sure you have the quadratic formula memorized. And then the second piece is, just like factoring, this does have to be equal to 0. So I do need to move that 5 over before I start. So I have x squared minus 8x minus 11 equals 0. And now I can label my a, which is the number in front. If you don't see one, it's a 1. My b, which is negative 8, and my c, which is negative 11. And now that I have those, I'm just going to plug those into the quadratic formula. Negative b, that means the opposite. So if this is a negative 8, I'm going to make that a positive b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then I'm just going to simplify it. So I have 8 plus or minus. Remember, when I square this, it will be negative, so 64. And then I have a negative and a negative. So this is going to be plus 4 times 1 times 11, which is 44, all over 2. I'm going to add those together. So 8 plus or minus 108 all over 2. 2. And then I need to simplify that 108. Just like I've been simplifying the radicals all along, I'm going to use my factor tree. So I'm going to take the 108 and use my factor tree. We can put a 2, 54, 2, and 27, 3 and 9, 3 and 3. And so when I simplify this, I have the 8 plus or minus. I can take a 2 and a 3 out, which puts a 6 out here. I have 1 3 that is still left, and that is all over 2. Now, if the number can come out of all 3 of the things on the outside, then I can reduce it. And you can see that a 2 can come out of everything. So I can divide this by 2, I can divide the 8 by 2, and I can divide the 6 by 2. So I have 4 plus or minus 3 square root of 3. And since I just have a 1 on the bottom, I actually don't have to list that.